For ease of analysis, instead of considering two channels that have a full bandwidth, we're just going to approximate these as a single tone sinusoid just for ease of our analysis. Even with the simplification, there is going to be a lot of math. You can go back and follow it as we go along, but just be prepared. All right, so what we've done is we've shown, as we've seen before, two inputs to a system, A1 cosine omega 1 plus A2 cosine omega 2. And we put these through a nonlinear amplifier that has a Taylor series. And just remember that Y is equal to alpha 1 A in plus alpha 2 A in squared plus alpha 3 A in cubed, and so forth. And what we've done is we've multiplied all of that out. So here you can see this is alpha 1, alpha 2, alpha 3. And we've multiplied everything out, and what I've done is shown you two pieces. The first piece is what happens to the fundamentals. So you can see that the fundamentals have their linear gain, and they also have the gain that we saw before, a nonlinear gain, but that's still representative of their original amplitudes. But then they have these terms here, which are intermodulation. So if you look, this is A2, whereas this is the A1 cosine. The second thing we get, and this is one of the big effects, is that we end up with two tones at 2 omega 1. Let's say this is 0. So let's go to 2 omega 1. So this is 2 omega 1 minus omega 2. Okay? And then we're going to take 2 omega 2. 2 omega 2 minus, sorry, I drew that wrong. This is 2 omega 1 minus omega 2, and here's 2 omega 2 minus omega 1. And what you see is here is we've got these two sidebands adjacent to our two initial signals, and their amplitudes are a result of the coefficients that we see here. These are called third order intermodulation products, and if you're wondering why third order, you can see that you actually have a cubed term right here from the two amplitudes, and we'll look at that more specifically in the next couple of slides. Intermodulation 3 products do not interfere with the main tones, so the question is, why would we be worried? And as you've probably seen before, it's because they interfere with the adjacent channels. A lot of times in our systems, what's different about RF than maybe some other analog circuit design is we're not only worried about how what we care about works, but we're also worried about not disturbing things around us because of the limited bandwidth and the fact that other people are using channels around us. And so here's a nice cartoon. If these are our two input signals, and this is our friend, omega naught, trying to transmit, if we have this intermodulation product, it will actually throw down and interfere right there on omega naught and transmit it and disturb our friend as they're trying to happily communicate at omega naught. And so they're both troublesome for the transmitter and in the receiver.